Hello everyone, this is an introduction to relational databases and SQL. Now, chapter 1 is an overview chapter, so it's kind of reviewing everything you did not learn yet. There will be a few points when I will dive deeper than the chapter goes, and there will be a few points, few places where I will skim over. So first of all, simple client-server system. There is a database server and there is a client. They are connected with a network. And the point is to put all the heavy lifting into a database server that has plenty of RAM, plenty of computational power, and plenty of storage. And just take the uh, queries or inputs from clients and return the result. And in our case, we will have a client who has application software and data access API, and client sends queries, and the database management system processes those queries and it also retrieves the necessary information from the database and then returns results. So database management system is the backend, and client software with application software data access API is the frontend. Now, SQL stands for Structured Query Language. It had a prequel. Structured query language started in 70s, and the prequel to that, I think, uh, was very similarly abbreviated. The same words. Fun point of history. All right. DBMS stands for Database Management System. Now, there is a file handling system where basically everything happens in one computer in one place, and all the processing is done on the clients, and client server system is of course beneficial, as we know, because the client does not need the processing power, the physical processing power and memory in order to do some sophisticated data aggregation and grouping or selection, and the server will do it and send it back. Okay, so let me go to actually something that we need to know and we need to understand well. So this is a table. This is not a database, although database can consist of one table. No interesting database will consist of one table. Only one table. Usually they have many tables. Now we need to see that database is really, table is really something that you have seen in Excel, for example. It has column names, it has rows of data, and a row is a record. Sometimes it's called a tuple as well. And basically, if you read the row of data and you take into account the column names, most of it will make sense to you immediately. Vendor name, vendor address, and so on, vendor city. This is vendor name, US Postal Service, and there goes the address and probably the phone number. And actually, in the previous video, you have seen this table. It is in the AP database, our main example for this book. And sometimes we have a record with missing data, null. And fun fact, nulls are not equal to each other. This null is different from that null. Why is that? We will see later. And what we need usually, or almost always, in a good database, primary key in each table. Primary key somehow enumerates or otherwise gives a unique value to each row. And here primary key is just an enumeration starting at 1, and I think going with increments of 1, not provided that all the values between 1 and whatever is the length of this table are included, but the logic is clear. So primary key should consist of unique values, and that values are used to identify the row. Vendor ID 1, vendor ID 10, this is the name, and so on. Now, columns contain one sort of data, whether it is vendor ID or vendor city. And in the intersection between column and row is a cell. So when each vendor name is in its own cell. And out of this list of things that I need to describe to you, we need to talk about composite key, non-primary key, and index. Now, we go up. Non-primary key. There can be another column here that uniquely identifies each vendor. That could be their business registration ID, whatever number goes there. And it could be an alternative key. It's a unique key, but it's not a primary key just by the matter of choice, and sometimes by the matter of security. For example, if you will be using primary key a lot, and if your non-primary key or unique key is some sort of private unique data, I don't know, I want to say a social security number, you don't want to be throwing it around a lot. And on the other hand, a primary key can be composite, so it can be composed of 2 or more columns. So over here, one column identifies each row, and it can be multiple. Sometimes you can use multiple columns instead. And finally, a notion of index. Currently, my school computers are somehow configured to, this access that I get at school, it has index turned off. And that makes searching, whenever I search for some file or a folder, slow. So the point of indexing, whether it is a file system, in a file system in Windows or in a database, is to make search and aggregations and certain kind of queries faster. So you want to index some of the columns, namely the columns that have either unique values or almost unique values, and we will learn that primary key is always indexed, no matter what. But indexing may speed up the overall performance of your database, meaning how fast you can return the results when the query comes in. And back in the day, it was really important which columns were indexed, and it still is. And back in the day, you organize the database with an idea of what kind of queries are going to come often, and with an idea which columns need to be indexed to respond to those queries faster. Nowadays, some of it is automated, and in fact, queries are pre-processed, and there are a bunch of data management systems and upgrades that allow that actually help you choose what you need to index based on previous queries and things like that. Okay. And now probably it's a basic concept, but also one of the most important basic concepts to get right away. So if you understand what I'm talking about right now, you are doing great and you're on the path to success in this class. We have two tables here. I'm going to zoom in. Actually, I showed you a very similar example in my previous video, in one of the introduction videos, if not exactly the same. Now, the above table is the vendors table, and we have vendor's ID here and vendor information here. And vendor ID is a primary key in this table that is a unique row identifier. And the lower table is the invoices table, which lists the invoices and invoice number, date, amount, and of course vendor ID, which vendor generated this invoice. So the first invoice that we see here, it was generated by vendor number 108, and we could look back and find this one. Now notice that one of the vendors is generating a lot of invoices, and that is vendor ID 123. And looking back, we see that this is Federal Express Corporation. Now, this is significant. The vendor ID here is listed multiple times. It is not in the invoice table, it is not a primary key, it is a foreign key, which is used to reference the data in another table. So that is a notion of a foreign key. The table, the invoices table over here, it has a primary key, invoice ID, no doubt about that, but it needs a foreign key, vendor ID, in order to go to be able for us to look back at the vendor information. And the relationship between these two tables is one-to-many relationship. So for every vendor, there may be several invoices or any number of invoices. But for any invoice, there is only one vendor. In this business model, like two different vendors cannot generate an invoice, which is probably how it is in real life. So this is also an example of one-to-many relationship. So this is some of the most important concepts: foreign key, primary key, one-to-many relationship. And I will come back to this and maybe talk a little bit more about one-to-many relationship. It's actually as good of a point as any to switch over to the actual AP database, and here is the database and the invoices and vendors tables that I was talking about. Let me select 1,000 rows, and the last of them is Federal Express Corporation, vendor ID 123. And if we open invoices in the same way, 123 pops very often. And I have already made an example of that, about that. What I want to do now is emphasize that there is another way to see foreign keys and primary keys in your table by creating database diagram. So we need to click on create a new diagram and highlight all the tables, and it's automatically creates a diagram. Now, these two tables are hanging, don't worry about those, but here is our diagram with relations between the databases. Golden key means this is a primary key. Vendor ID is primary key in vendors. And now let's check out the relationship to invoices. The relationship to invoices is that vendor ID is a foreign key in invoices, and this is a one-to-many relationship. Like this figure eight-ish thing is a uh, many, and key or number one that would be here is one. So this is one-to-many relationship. One vendor can have multiple invoices. And there are other relationships for you to study, and as far as I can tell, all of them are one-to-many. And all of them are between a primary key and a foreign key. Also, interestingly, over here, invoice line items and invoice sequence, this is a composite primary key. And let's switch to another way of understanding these tables. Let's look at columns. Invoice ID. So columns of invoice line items. Invoice ID is both primary key, and foreign key, and the data type integer, and the values should not be null. Invoice sequence is also primary key, and that's how we know that the primary key is composite. And this is a foreign key account number that goes to some sort of accounts, GL accounts. I forgot what that means, but don't worry about it right now. In any case, it's a good idea to, when you're working with a database, it's a good idea to understand what the database is about, what is the business model. And if you were to create your own database, you begin by thinking about a business model if you are making it to help run a business. Invoices in a business, invoices have like line items. Think about like invoice is a check that you get in Walmart, and invoice line items is all items on this check. So that is how you can explain in human terms the relationship between invoices and invoice line item. And in any case, we can see how those invoice line items look like. Select top 1000 rows, and we have invoice ID, invoice sequence. See, for some of them, there is more than one item on the invoice. So invoice ID is the same, it's the same invoice, but there are multiple items, different descriptions, and this is the meaning of this invoice line item. In any case, whenever you forget what this database is about, these are all the ways, some of the ways you can poke around and understand what it is. You can look at first rows of this database or some rows of this database, column names, the specific roles that they play, such as primary key, foreign key, and note that sometimes it's a composite primary key. And really, it does not make much sense to write SQL queries without understanding the underlying database. Because usually the way the queries will be in our class, that will be reflecting of some basic business questions. Like, write a query which counts the number of invoices per vendor and total of those invoices. That would be an interesting aggregation query that you solve with group by, and we'll get there. Okay, so you can actually open columns and inspect what happens inside each column. Primary key true. Sorry for the gray, I don't know how to make it more bright, or maybe you guys can just click yourself and see what these values are. There is data types and allowing nulls, not allowing nulls. This specific column does not allow nulls, and so on. And this is one place where you could be changing this default values, or values that were selected when somebody created this this database. There is also keys and for keys for this specific table, and you can explore those. And sometimes there are constraints, kind of being a primary key or a foreign key is a constraint, and they are not like constraints like that are defined as can be defined as constraints, but they are not listed in the constraint folder. All right, let's move on. Now, there is a bunch of different data types. Some of them are static, some of them are dynamic, and bit means 0 is 1 and 1. Those are various integers, money formats, time formats, bunch of time formats actually. Character and var character, the difference is that you can create a string of fixed length. For example, if you need to a column for the state codes, like LA for Louisiana, TX for Texas, because those can consist of 2 letters. Or you can do a varchar if you want strings to be of variable length. Okay. Null value, as I was saying, null value is really like no value. It's not a default value, it's a null value. And there are some nulls here, and nulls are not equal to each other. Different nulls are not equal to each other. There is a default value that you can define when defining your data. And there is an identity column, which is the ID column, and it can automatically increment, for example, ID by 1 when you are adding data to your table. All right, so let us look at the AP table. Yeah, so this is create AP table that comes with Murich's book, and if you follow your the instructions, you have already used it, ran it once, and installed it. I increased the font so that you can see it better. So use master, that is not an SQL statement, but let us read this. First of all, if database AP already exists, we want to drop it and rewrite it. Otherwise, it would error out if we run it twice. Now, this is a data definition statement. We created a database. This is also a data definition statement. There is no specific data. There are no values there. We are describing a table. We're creating a table and we are describing the columns. So this is the name of the column. This is the data type. It's an identity column and it cannot be null. Similarly, last name varchar, that means the last name can be up to 50 letters long, and it can be null, and so on. So we do a bunch of create tables, and we actually define, using this statement, we define primary key. And some tables don't have oops. Expand it back. Some tables don't have primary key defined. You remember in our database diagram, this one was isolated, not related to anything. That's okay. That means we are not using it actively. Okay, so this is another definition of primary key, invoice line items, and this is how you can define a composite primary key, and that's one of the things that we will do later in the course. And so on. So far we do data definition, creating tables, describing primary keys, and vendors, and so on. Okay, so now we are actually manipulating data. We are actually adding data, and this is data manipulation language. Insert, contact updates, and there is a vendor ID here, and then last name, first name values, and so on. So now we start to actually add data to it. And you can see the syntax of doing that. So row after row, I can try to fit the whole statement in one line. So this describes the order of columns, and in the same order, we are populating the values. So 122 is the vendor ID, invoice number is here, and so on. And this is casting a string into small data type that we will talk about and do. And this is creating a database. So and finally, we are indexing. So indexing will improve the performance of queries, and we can index, for example, by invoice date. And by terms. So this is in anticipation of working with queries. We can create a bunch of indexes. Okay, so that's how this create IP script works. And in the end of the semester, fun fact, you will create a similar script. You won't have so many lines of data, that's crazy to come up with it by hand, but you will be creating a database with multiple tables and managing indexes and choosing your indexing columns and choosing your primary keys and so on, and describing the data types that you want your data to have, like they are doing over here. Okay, let me go back to the slides. Now, there are some other file systems and relational databases require more resources, and they provide a better flexibility in retrieving, grouping, and otherwise transforming data. So I will not talk much about that. And I need to talk about relationships. So the most ubiquitous and the most important relationship to us is one-to-many. For example, for one vendor, there can be multiple invoices, but each invoice is generated by a single vendor. At least that's the business model that this database follows, or since it was generated by a business, that's what the business does, how the business is. And you want to understand each of those relationships. Like, let's get this one out of the way. Ad hoc relationships. This is certainly important. If you have a database, you can come up with your custom query if you're curious about something. Maybe you want to group by values that are not clustered, that were not indexed, and it's just one-off thing, or there is some parametric query that you run for different values of parameters. That would be an ad hoc relationship that you create temporarily to achieve your goals, your business goals, or to learn more about your data. And it's not really described in a database. The DBMS is going to retrieve the results, and after that it's going to be forgotten, or maybe next time you'll need it with completely different parameters. But there are relationships, like I showed in one of the previous slides, between vendor ID and vendor ID in two different tables. One table is vendors, where vendor ID is primary key. Another table is invoices, where vendor ID is a foreign key. This is a one-to-many relationship. And there is also a many-to-many relationship, and that actually deserves a separate diagram. Here is an example of many-to-many relationship. Students. There is a table of students with Alex, Bob, and many other students. And classes. Like C Tech 270 and C Tech 150 and many other classes. So those are two tables. They contain whatever information they contain. But there is a relationship between them, which is many-to-many. So Alex can take both classes. And definitely Bob can also take one of those classes if Bob wants to, and maybe Cindy can take no classes this semester, and so on. So this is a many-to-many relationship. One student can take many classes, and one class has many students, hopefully. Otherwise it gets canceled. So this is a typical many-to-many relationship. In relational databases, it will be resolved by creating an intermediate table, and like enrollments, which basically pairs Alex student ID to class ID and Bob student ID to another class ID. So there will be a pair of student ID with class ID and student ID with class ID. So to resolve many-to-many relations. We'll get back to this later, and overall, I want you to start having some idea about each of these things that I'm emphasizing. If it seems a little bit too vague, then we will come to it, and these three notions will be like in the core of many chapters, and we will talk about them in various ways. All right. History corner. In 1970, Dr. Cod developed relational database model, and then they started to develop the SQL, and eventually they started to release the database managing systems, and this is in National Institute of Standards, which kind of codified what is SQL and continued to update it. And let's move on. So knowing standard SQL is kind of the core that allows you to read statements and understand what the statements are doing. And on the other hand, if you are working with or on any application, it requires some more application-specific or area-specific dialect of the language. And TSQL is the dialect that is used by Windows SQL Server, and that's what we are learning. There is MySQL. There is some other SQL dialects. So if you are Googling something, please make sure that you Google it in the right dialect. And here we go. Two kinds of statements. Data management language statement, select, insert, update, delete, the four big ones. And data definition statements, create database, table, or index, alter table or index, drop table, database or table or index. Drop means remove. So data modification is mostly for people who are using databases, like data analysts, scientists, and so on, and data definition, and as well as maintaining privileges is what database administrators do. All right, and now we see quite a huge statement. This is actually the statement from Create Database AP, much simplified. This is a data definition statement, so we are not defining any specific values of this data. We are defining what columns will be, like invoice, vendor ID, invoice number, and invoice date, and so on, by describing their data type, stating whether nulls are allowed in that column, stating whether describing, well, it is an identity column, means that it will have unique values in our table. And we also state that this is a primary key, and so on. We can choose default values, default 0. That means if we don't specify when adding data, when we don't specify payment total values, then by default it's 0. And we can specify reference and do some other things that are of lesser interest to us now. Okay, so alter table, that is adding a column. Balance due is a column. The data type is money, and nulls are not allowed. And we can also create or drop, and alter means changing like the structure. Again, we're not changing the actual data, like replacing 1 with 5. We are changing, we can change data type, we can add a column of a certain kind, or we can remove something, drop something. And if this is the invoices base table, okay, so just familiarize yourself quickly. This is the invoices table, and in my AP database, it's also there. I can quickly do the same thing as I did previously to create it. here are some values. Sorry, not to create it, by display the top 1,000 rows of it. Of course, there is much less than 1,000 rows in it. And from the column names and from the overall values and structure, you will understand what it means. Maybe not all of it. Terms ID, you would have to look at what these terms are, what this is about, and figure it out from the terms table. But we can select information, select, retrieve, and sort. All right, so select invoice number, invoice date, invoice total. So I'm selecting certain columns from invoices. And also I'm selecting a computed value of these 3 columns. First of all, those are columns from the original table: invoice total, payment total, credit total. And I take one minus the second one minus the third one. And this column is called balance due now. So based on existing 3 columns, I can compute a value, and I can assign the values that I compute to a new column. What it means is, for every row, for the corresponding cells, the mathematical operation minus will be performed, and the value will be specified. Now, unfortunately, in this snippet, there is a lot of zeros, so we don't really subtract anything. But if we actually run it, we'll be able to filter it a little bit. Okay, so as balance due from invoices. So we're selecting data from invoices, and it's not just select columns as they are. You can also perform an algebraic or any kind of manipulation between the values in these columns and save it as a new column. But we also throw in some conditions. A condition in this case. We want to select only those where the difference is bigger than 0. So balance due, this is exactly the same expression as was described over here. So basically where balance due is positive. And finally, order by invoice date. And order by invoice date, you can look at it. The dates are increasing. Okay, hopefully that makes sense. And I'm actually going to copy this, if I did not copy it while preparing for this lecture, and run it, and maybe we'll see. Yes, I think I copied it. Here, let's rerun it. Here is the output. So hopefully you can see this. Let's concentrate on this row. So invoice total was 20,551 and 18 cents. The credit was 1,200. It doesn't matter where this credit is came from. So this value minus payment total minus credit total equals to balance due 19,351.18. So indeed, this formula seems to work. You can actually highlight one of the columns and make sure you actually apply this formula like in your head and get the right value. That way you will understand it. And just for fun, we can comment out a line like this condition, rerun, and see, oh, that way we are not filtering by any condition. So most balances are 0, except for some that we actually picked previously where we had this condition. And in many cases, the invoice total is exactly equal to payment total. And if you don't like this condition, you can, just out of curiosity, where credit total is greater than 0, where did they get this credit and what does it mean? So let's look at the numbers at least. Here they are. So the credit total is not 0, only in 3 columns. So copy paste one of those queries. By the way, if you copy paste directly from the slides and you have slides in, I think you should have access in your to these queries in student downloads from Morage's book. That's what they are. Sometimes when you copy paste, for example, I honestly was copy pasting from the slides. The minus gets, when you copy paste, interpreted as a dash, so you'll have to fix some errors in there. But in any case, maybe after a little bit of editing, it should work. And it's fun to play with it and figure out how exactly does it work. Change it. If you want to understand something, try to change it and see what it does when you change it. Okay. Well, there is a bunch of select statement. This also makes a lot of sense. So there is a join here. We join two information from two tables. Don't worry about the inner join. That basically, this part of the expression means that we are only taken from the rows that contains identical vendor ID. Rows from vendors identified with rows in invoices if they have the same vendor ID. And then we take from the corresponding tables vendor name, invoice number, invoice date, invoice total, but only where invoice total is bigger than 500. And feel free to actually try this query and see how it works. This is the result. So only the totals that are bigger or equal to 500. So depending on your, this is actually, you see that some of the vendor names are repeated because what we are selecting is invoices. So these two are invoices from the same vendor on different amounts and on different days. All right. So the result set is what the query is returning, and base table is the table in the database. We can use calculated values, and calculated value is, for example, difference of the columns that we have seen in example above. Again, for any of these things, there will be like a chapter when we will hammer this and get a lot of details out. Query is just SQL code, coding statement, full statement, and join and inner join is the same. Outer join is different from inner join. There is also left join and right join, and this will be one of the more complicated for students who see this in the first part. This will be one of the more complicated parts of the course when you will need to join two tables and aggregate data from them to get something that hopefully makes sense from as a business question. All right. This is a way to insert into the table invoices. We list the columns for which we want to insert. And if one of those columns have a default value, we don't have to list it. We just skip it and insert only to the values, to the columns, the values that we need. And the order matters. So 12 is going to be vendor ID, and this number is going to be invoice ID. So order matters. So order of these numbers corresponds to their meaning. And if you skip one of the, just decide to skip a couple of columns and their corresponding values, then they can be initialized as null if that is allowed by your data definition. table definition, or it will throw an error if you are trying to not give a value where you are required to have a value. So this is another way to update something, set credit total to this, where invoice number is that. So if you wanted to give credit to somebody with this invoice number, you can run this statement. And where terms ID is 4, this can change the invoice due date. So we are adding 30 days to the invoice due date. And to figure out that it is days actually and not something else, we would need to look at the data type of this variable. And sometimes we have to be a little more specific than this. Well, you can delete some data. You can delete rows from invoices where invoice number is this. So it will search for the invoice number equal to that, for the row where invoice number is equal to that, and delete. Or delete all paid invoices. Not a good practice for a business because you have to have a purchase history to be safe in case somebody decides to do a return and whatever. All right, and now good practice versus bad practice. And again, you can use the Management Studio to turn bad practice into good practice. Let me quickly do that. This is in bad practice. I'm going to copy paste. I'll have to fix some copy paste errors. And yeah, minuses should be minuses and not dashes. So it doesn't understand minuses. Okay. Now I'm gonna design this in the editor. And here we are now. It's reformatted in a pretty way, exactly the same thing. Presumably this is all good practice and pretty. But what good practice actually is? And they rewrote it, the same statement, in a more readable way, like this. So capitalization doesn't matter in SQL. So invoice number with capital letters is the same as invoice number with no capital letters. But it's definitely more readable if you quote the names of the table columns or tables exactly. And we will see some recommendations later. I mean, we will also talk about it during the rest of the course. Let's first look at the block comment. Block comment may remind you of some languages that you learned, or maybe you will learn this semester. And single line comment, double dash, I already showed that. Comments are for humans, they are not for SQL. And third, each new clause in a new line, you don't quite know what is a clause yet. For example, where or from is a clause. Break clauses into multiple lines and indent continued lines. That's what they are doing over here. So this is a clause and it continues over 3 lines. Capitalize the first letter of each keyword and each word in the column and table names. So that's a way to do it. Okay. And each statement with a semicolon. You can notice that they work without a semicolon in often, and we'll talk about that later. In any case, it's better to do that. Use comments only for portions of code that are difficult. So as you get better with it and you work with colleagues who are good with it, you might comment different things. All right. So there is something called a view, and view is sort of a permanent query that is stored in a database. And that's, I guess, all we're going to do with it, say about it. Notice the star here means select all. Select all from vendors mean where vendor state equals California, order by vendor name. So what is vendors mean? That is a view. And from a view, we did a select statement, select everything where vendor state is California, and then order by vendor name. So we're ordering, it's an increase in order by default, but the vendor state is the same by the filter that, or condition, I say condition or filter interchangeably, that we introduced here. All right, this is a procedure. Procedure is a function, it has a variable. This procedure has a name sp vendors by state. At state var, this is a variable state. The type of the variable is character of length 2, I mean string of length 2. And what this procedure does is here, where vendor state equals to state var. So each time you call this function, this procedure, you are going to specify the variable and execute this procedure with the variable California. And we get exactly the same result. Okay. So there are stored procedures. There is control of flow language. So in a procedure, you can specify what to do in this or that condition. There are some specific procedures called triggers. For example, whenever you update a table in your data set, you will trigger the trigger. The trigger can, for example, check the validity of your data or consistency of the data with values in another table, with existing values in some way. For some columns like IDs and primary keys, it's done by default, but also you can define your own triggers, and it's a good idea to do that. There is finally a user-defined function. I doubt we will get there if you look to the corresponding chapter of the book. This would be like chapters, if I'm not wrong, 14, and this is 18, and so on. So it's advanced topics in the end of the book. And you can sort of work with SQL or SQL execute SQL queries without writing SQL queries. So there is .NET applications and Java applications that use their own API, and you can wrap your queries into those, or you can, there is a way to use another API and completely make it look like working with a class, like something.do, and that will be translated to a SQL query, and the result can be returned. All right, so I'm not going to go into details here, and feel free to review it using the book. Maybe we will look at this little cute C# method. So you don't need to know C# here if you know Java. It's really similar to Java. You are initializing new objects and you are working your way to basically send an SQL query. And when you, this is a variable at vendor ID, And when you are actually sending this query, you are supposed to specify the vendor ID. So vendor ID is a variable in your C# uh, uh, function, in your C# method, and it's fed here. So you will specify when you call this method, it's fed here into add with value. And that's how you can wrap the function into your SQL query into a C# function. Also, this is a dynamic query. They have pros and contras. Dynamic query means that part of it is specified during the execution, namely parameter of this query. We are not going to say much about it either. And I guess that's it for this chapter. Complete the quiz. The quiz, I tried to emphasize everything that was on the quiz, so you should be able to do it no problem. And complete the assignment and move on to chapter 2 that will speak more specifically about the Management Studio, how to use it and what you can do with it.